Imagine this. Right now, millions of packets are moving across the internet. Emails, banking transactions, video calls, cloud applications. Almost all of them are encrypted. That's good. Encryption protects our data. But here is a problem. Attackers use encryption to malware, command and control services, even stolen companies' data often hides inside normal HTTPS traffic. Years ago, security teams could simply read the packet. Today they can't. Modern SOC analysts don't investigate the content, they investigate the behavior. And today you will learn how. This week has 5 parts. First, ports and protocols, then TCP and UDP, after that, the OSI model, finally, how modern SOC teams detect encrypted attacks. By the end of this video, you will understand how network communication really works and why every SOC analyst must master it. You already know what an IP address does. It finds the right computer. But here is another question. What if that computer is running a website, an email server, and remote access all at the same time? How does the data know where to go? That's the job of a port. Think of an IP address as an apartment building. The port is the apartment number. Same building, different doors. As a SOC analyst, you don't need to memorize all 65,000 ports. You only need to recognize the important ones. Some of them are port 22, SSH, secure remote access, and port 53, DNS, the internet's phone book, and port 80, HTTP, regular websites, and port 443, HTTPS, encrypted web traffic, port 445, SMB, Windows file sharing, a favorite target for ransoms, port 3389, remote desktop, one of the most abused ports in cyber attacks. Here is something important. Attackers rarely use strange ports anymore. They use your normal ones, HTTPS, DNS, HTTP, because nobody wants to block them. So your job isn't finding a strange port, it's finding strange behavior on a normal port. Imagine sending an important package. Would you check whether it arrived? TCP does. Before sending data, TCP creates a connection. Then it confirms every packet arrives safely. Reliable, accurate, but slightly slower. UDP is different. It doesn't wait, it doesn't ask. It simply sends faster, but with no guarantee. Every TCP connection begins the same way. First, the client sends a synchronized flag and sends an initial sequence number. Then, the server responds by synchronizing its own sequence number and acknowledging the client's number. The client acknowledges the service number. The virtual circuit is now established. Attackers abuse this process. During a SYN flood, thousands of fake requests never complete. The server keeps waiting until it runs out of resources. Before attacking, hackers also perform port scans. They are simply checking which doors are open. The OSI model is a framework of 7 layers that explain how data travels from an application on your computer to another application on another device. But for a SOC analyst, it's much more than that. It's a map of where cyber attacks happen. Every attack you will ever investigate occurs at a specific layer. And once you identify that layer, you know exactly which log to analyze, which tool to use, and where to begin your investigation. So let's climb the OSI model one layer at a time and see the attacks waiting on every floor. Layer 1, Physical. This is the layer where cables, radio signals, and the hardware that connects everything together. The attack type. An attacker plugs a rogue device into your network or simply cuts a network cable. Because sometimes physical security is cybersecurity. Second, data link. This layer handles MAC addresses, switches, and Ethernet frames. Attack type: ARP spoofing, MAC flooding. This is where attackers positions themselves in the middle of communication, making it the classic man-in-middle layer. Third is network. Here, packets are routed using IP addresses. Attack type: IP spoofing or routing manipulation. Instead of stealing your data directly, attackers manipulate where your traffic goes. 4. Transport layer. This is the layer where home to TCP, UDP, and network ports. Attack type: SYN floods and port scanning. Everything we learned about TCP and UDP happens right here. Fifth, session layer. It creates, manages, and ends communication sessions. Attack type: session hijacking. If an attacker steals your session token, they can impersonate you without ever knowing your password. 6. Presentation. This layer is responsible for encryption, encoding, and data formatting. Attack types: SSL stripping, protocol downgrade attacks, and exploiting weak encryption algorithms. 7. Application. Finally, the application layer. This is where users interact with applications through protocols like HTTPS, DNS, and SMTP. Inside these 7 layers, majority of cyber attacks happens at layer 2 with ARP spoofing, and layer 3 with IP spoofing, and with layer 4 SYN floods, phishing, malware, SQL injections at layer 7. When an alert happens, the first question isn't what the attack is, it's which layer, because the layer tells you where to investigate. How modern SOC detect encrypted attacks? Today internet is encrypted. So how do SOC analysts still catch attackers? They study behavior, not content. They ask questions like who is communicating, how often, how much data, for how long. Even encrypted traffic leaves patterns: regular connections, unusual uploads, suspicious destination, and different fingerprints. Modern SOC platforms combine network detection and response with endpoint detection and response to uncover hidden threats within encrypted traffic without needing to decrypt the payload. The future of cybersecurity isn't reading packets, it's understanding the behavior. So, today you have learned how devices communicate, why ports matter, how TCP and UDP move data, how attacks exploit network communication, why the OSI model is a map for investigation, and how modern SOC analysts detect threats even inside encrypted traffic. Networking is now complete. In the next episode, we will learn one of the most important skills every SOC analyst must have: Linux. Until then, keep learning, keep investigating. Subscribe to Trinetra SOC right now. Hit the notification bell so you never miss a single video. The digital world needs defenders. I am Agent Netra and I will see you in the next video.